Yes, welcome back friends. We have already discussed introduction for laws of motion, then Aristotle's law and Aristotle's fallacy. Now we are going to the next topic, that is law of inertia. This is 5.3 law of inertia. Law of inertia was formulated by Galileo Galilei. Galileo, after doing a lot of experimentation, he came to one law which is known as law of inertia. Let us write down what is the statement of law of inertia. The law of inertia states that the body remains in a state of rest or in a uniform motion unless it is compelled by some external force. The body remains in a state of rest or a uniform motion. Rest or uniform motion unless
तर सब्जेक्ट को कोई एग्जाम वाला है क्या?
it is
नोटिस है आपको पढ़ना
compelled by external force. Once again I repeat, this is law of inertia. A body remains in a state of rest or uniform motion unless it is compelled by external force. This is the statement of law of inertia. But coming to this conclusion, there was a lot of experimentation done by Galileo. First set of experiment, he divided motion into three parts. One, objects moving. Whenever objects, he considered one inclined plane, an object moving upward on this inclined plane. Then another thing he considered object moving down inclined plane. And third thing he considered object moving on horizontal plane. Let us consider this situation first. Objects when moving and down from inclined plane, its velocity goes on increasing. Here it accelerates. When it is moving down inclined plane, its velocity goes on increasing. It accelerates. On contrary to this one, when object is moving upward on inclined plane, it decelerates or retards. Here its velocity goes on decreasing. But what about when the object is moving on a horizontal plane? And this one, it is, if an object is moving on horizontal place, it moves a finite distance and comes to rest. This is because of friction. If friction is totally removed, then an object moving on a horizontal plane continues with the constant velocity. This is the one set of experiment he has performed. Once again I repeat, Galileo studied or he formulated this law by studying motion of an object on an inclined plane. First is, when the body is moving down from an inclined plane, its velocity increases, therefore it accelerates. When body is moving upward on an inclined plane, its velocity decreases, it decelerates. Very obvious question came in his mind. If the body moves on a horizontal plane, what will happen to the body? And to his surprise, he found that after finite distance, object stopped. When he found this reason why the object stopped, he came to the conclusion that this object stopped because of friction. If friction is totally removed, the object will continue to move in uniform motion or with a constant motion. Another set of experiment he considered, that is here, he has taken this type of arrangement, two inclined planes. The slope of this one and slope of this one is same. Slope of this inclined plane and slope of this inclined plane is same. He considered friction 0. It is not possible, but in ideal case he considered friction 0. When the ball is released from this one, it moves and then it climbs. It is climbing up to equal height. It is little less but not greater. The ball, this height and this height attained by the ball is same. Ball climbed up to equal height or little less. It never climbed more height than this one. Another thing he did, that is this slope he kept more and this side slope he decreased. This side slope is less. This side slope is more. Again he released ball. Ball went here. Ball climbed the same height or little less. But in this case it travelled longer distance. In this case he travelled longer distance. Third case, this another side absolutely he made it free. No slope to this side. When the ball is released, it travelled longest amongst these three. Now in these three situations, here if the friction is removed on this third one, then the ball continues to travel for infinite distance with the same velocity. This is a very important conclusion. In other way, this discarded Aristotle's law. It means that whatever external force is supplied to an object, it is used to overcome frictional force. To make an object move with a uniform velocity, external force is not required. For example, here, the body is moving. The force, external force is there, and there is frictional force. This is F external. There is a frictional force. Both are equal and opposite. Therefore, net force on the body is 0, and then body continues to move with uniform motion, uniform velocity. So when the frictional force is encountered by external force, net force acting on the body is 0, and then body continues to remain in motion with the same velocity. It indicates that he had reached to the conclusion that the rest position and uniform motion, these are not two different situations. In rest position, net force acting on the body is 0, and when the body is moving with a uniform velocity, the net force acting on the body is 0. If we want to change these states, that is the state of rest of a body and the state of uniform motion of a body, then external force is required, which is called as law of inertia. A body remains in a state of rest or uniform motion unless it is compelled by an external force. This is called as law of inertia. It is called as law of resistance also. So once again I say, by doing this experiment, with the Galileo came to the conclusion that the rest position and the state of rest and the state of uniform motion are not different from each other. When an object is at rest, net force acting on object is 0. When object is moving with uniform velocity, net force acting on object is zero. And therefore, to change these two states, external force is required, which is known as law of inertia.